So now I'm going to go through how to calculate MN for doubly reinforced beams or beams that have compression steel like this. As I said earlier, the MN is going to increase by about 1%, but we'll go over this so you can learn how to do this just in case you, for some reason, need to know how to do this. We're still going to use the same two basic equations. Sum of forces in the x direction equals 0, and sum m equals 0. So we still have C equals T right here. The only difference is that C now has two components, the regular C of the concrete that we had before, but now there's C of steel due to the compression steel. Because there are two compressive forces, what happened is that M is T times Z, but we would have to find the centroid of those two compression forces. So what I'm going to do is M equals C times Z. So M equals the sum of C times Z. So you have the C of the concrete, and its distance from the tensile force is still D minus A over 2, like before. And the difference is now there's C of steel, and its distance, let me erase some of this here. So the distance to C of S, this distance here, okay, is just D, which is the distance from the top to the steel, minus the distance from the top to the compression steel, which we call D prime. So D minus D prime is this moment arm right here, D minus D prime. And so you get C of concrete times Z of concrete, C of steel times D of steel. You know how to calculate C of concrete. You know how to calculate D minus A over 2 once you solve for A. D minus D prime, that's just a constant that be given in the dimensions. And so the real tricky part of this problem is, what is the compression force in the compressive steel? And the reason it's tricky is, unlike the tension steel, the compression steel has two possibilities. It could be yielded or not yielded. And there's no way to tell a priori. I guess there is an equation you can use, but I can never remember it. And so what I do is I just guess that AS prime is yielded, solve everything, and then check. And if it's not yielded, then I'll have to redo the problem. So if you're lucky, you do the problem once. If you're unlucky, you do the problem twice. And so what I thought I'd do is I'll take a break here, and then we'll go over first what to do if AS prime is yielded, and then I'll have another video if AS prime is not yielded. Okay, so that'll be the next video.